An empty swimming pool is a massive liability, but with a few modifications, it becomes a high-yield, closed-loop aquaponic engine. In the next 6 minutes, we are going to build that engine. We'll construct DIY filtration, build floating watercress rafts, and introduce Nile tilapia using 0 chemicals. Before starting, check your local zoning laws regarding urban agriculture. Some municipalities restrict aquaculture or require specific setbacks. Second, inspect the pool shell. It must be completely free of structural cracks. Converting a pool solves a major space problem for urban farmers. You already have the heavy infrastructure in place to produce an independent, self-sustaining food source. Traditional pools rely on chlorine, algicides, and stabilizing chemicals to kill biological growth. Even trace amounts of these residues will fatally shock aquatic life and destroy the bacteria we need. You have to drain the pool completely. Scrub the walls and floor vigorously, using only non-toxic methods. Do not use standard chemical cleaning agents. This purge dictates whether your system survives. A perfectly clean shell is the required foundation for the entire ecosystem. Aquaponics requires a 2-stage filtration system. Water has to be cleared of physical waste before it can be chemically purified. First, water enters the leftmost mechanical filter chambers, where sponges physically trap solid waste. Then it flows into the adjacent biological filter. Here, white bioballs and ceramic rings provide massive surface area to house beneficial purifying bacteria. To keep the bacteria and your future fish alive, you need high oxygen levels. Install an aerator or route the return water through a waterfall. Pairing mechanical waste removal with highly oxygenated biological filtration replicates the exact purification process found in a natural, flowing river. Fill the clean pool with tap water, then turn on the pump and aerator. Let them run continuously for 3 full days. This allows the chlorine in the municipal water to completely off-gas. Now we cultivate the bacteria by feeding the ghost. Dose the empty pool water with pure ammonia. This provides the exact food source needed to breed our beneficial bacteria colony. This diagram outlines the nitrogen cycle. Filter bacteria consume toxic ammonia, converting it to nitrites, then nitrates, plant fertilizer. Test daily until ammonia and nitrites drop to 0 and nitrates steadily rise. If you skip this cultivation phase and add fish immediately, their waste will cause a lethal ammonia spike. Patience here secures the system. With the water rich in nitrates, it is time for the plants. Deep water culture, or DWC, is the most efficient method for growing watercress directly on the pool surface. To build a DWC raft, start with a clean tray. Zip tie foam to the sides. Line the bottom with hemp and sprinkle watercress seeds. As the roots grow down through the trays, they absorb nitrates from the water. Above the surface, these floating rafts spread out and cast deep shade across the pool. In a standard pool, full sun causes massive algae blooms and overheats the water. This passive biological layer blocks that sunlight, naturally regulating the temperature below. The final addition is the Nile tilapia. Before buying fish, verify your water parameters. pH must sit between 6.8 and 7.2, and the temperature should hold steady between 78 and 85 degrees Fahrenheit. Maintain a safe stocking density to avoid overloading your filters. The standard rule is 1 fish for every 5 gallons of water. When your fingerlings arrive, do not dump them straight in. Float the sealed bags in the pool for 20 minutes to equalize temperatures. Then open the bag and let the fish swim out freely into the protective shaded root systems of the rafts. The tilapia eat their feed and produce waste, which feeds the bacteria, which feed the plants. With the fish integrated, the biological food engine is fully active. This animated diagram maps the continuous loop in action. You add protein pellets, the fish create waste. The biofilter converts that waste. The watercress roots absorb the nutrients, and clean water flows back to the fish. Your ongoing maintenance is straightforward. Monitor your water temperatures and rinse your mechanical filter sponges every week or 2. However, never rinse your biofilter media with chlorinated tap water, or you will kill the bacteria colony. By combining proper filtration mechanics with the nitrogen cycle, you have repurposed a sterile concrete pit into a living, high-yield food farm. Check the description below for full equipment lists and scaling guides.